Hello everyone, welcome to the Digital Systems and Applications Lab. So this is where the computer engineering students gain hands-on experiences with microcontrollers, FPGA boards and other essential lab equipment, and this helps them to build real-world solutions. So today we have with us Associate Professor Colin Tan, who will bring us through the lab and its exciting projects. So Prof Tan, can you tell us a bit more about yourself?
Sure. It's nice to meet all of you. My name is Colin. As mentioned, I'm an Associate Professor at the Department of Computer Science, School of Computing. And in addition to teaching computer engineering courses like Engineering Principles and Practices 2, EPP2, I also teach the Real-Time Operating Systems class. And in the Department of Computer Science, I teach the Regular Operating Systems class as well as Computer Organization.
So Prof Tan, can you tell us a bit more about this lab and the role that it plays in the computer engineering program?
So this is of course the Digital Systems and Applications Lab. It's been generously given to us by the Department of Electrical and Computer Engineering, and you can see that in this lab there's lots and lots of equipment that help the students a lot. So for example, over here we can see things like oscilloscopes, signal generators and power supplies. And also I think the other beautiful thing about this lab is that the way that it is laid out is that you will notice that it is laid out exactly for small group work. So for example, right here you can see that the groups work together on one side of the table, on the other side of the table, and in the middle there is a common working area where they can get together to work on projects.
So I see that you have a lot of electronic components here. How do the students use these to develop technical skills?
That's a very interesting question. So here I'm holding in my hands an Arduino and a breadboard. And with these, we teach our students basic things like microcontroller programming. Now, of course, Arduino can be programmed by even children as young as 10 years old. But here in the computer engineering program, we teach them something much deeper, in particular things like bare metal programming. Now, from these basics, we also teach them things like integrating with sensors and actuators, as well as other very useful skills like soldering. And once they have learned all of these skills, they then go on to build non-trivial technical solutions. For example, over here, we can see a remotely piloted vehicle where the students design communication protocols to control these vehicles, as well as to make use of advanced devices like this LiDAR over here to help to navigate. Now, one thing I'm very proud to say is that this computer engineering class, which is called Engineering Principles and Practices 2, it has won the Innovative Teaching Award.
So Prof, earlier you mentioned the EPP courses and they do seem like they are quite integral to the students. So how does this help the students transition from theory to practice?
Well, that's one of the very interesting things about being an engineer. So as in our engineering programs, we learn a lot of very cool theories and equations, but once we actually translate them to real-world products, we encounter a lot of problems. So let's take a self-driving vehicle, for example. In addition to having the algorithms deal with, for example, input streams on the camera about pedestrians and so on and so forth, it also has to deal with unexpected things. For example, sunlight reflecting off a sign, causing the sign to be misrecognized. Now, here in EPP, right, we simulate a lot of these things through, for example, giving them robotic platforms where the wheels don't turn exactly at the same amount, even they are given the same signals. And here, what happens is that the students then have to deal with this frustration and annoyance of the vehicle not being able to move in a straight line. Now that sounds like a very cruel thing to do to our students, but I think we have to understand that these are realities that they face in the real world, and by training them through this kind of experiences, it helps them to come up with creative solutions to get around the limitations of their platforms.
So aside from the technical skills that you mentioned, what other key takeaways do the students have from working in this lab?
I think two very important skills that engineers need to have. The first is time management. So EPP2 and EPP1 for that matter, being flipped classrooms, the students have to watch the videos of the lectures ahead of time before coming and starting the lab. And this means that the students need to have discipline as well as good time management in order to fulfill all of these things. Now, the second important skill that an engineer must have is an engineer must be able to work in teams. The days where we have the lonely genius, these days are over. They cannot exist anymore. And today we solve non-trivial problems working together with teams. And to that end, what we do is that we assign the students to random teams so that they are forced to work with people they're not familiar with. But the beautiful thing is this, we always see that as the course progresses on, they become close friends. And by the end of the project, these teams, they form very close friendships and they are very well bonded.
Thank you, Prof Tan, for the tour. It is inspiring to see how the students turn ideas into their solutions with hands-on experience. We hope that this gives you a good glimpse into the world of computer engineering. Thanks for watching!
Thank you, it's my pleasure.